Alright, so let's do something crazy here. Let's take a definite integral, but let's integrate with respect to y. Now, this is very different on a graph, but in procedurally, this is the same exact thing. So it may look a little daunting, but it's really not that big of a deal. So let's go through what we're talking about real quick. Preliminarily, before we get started, if you're not sure about the difference between definite versus indefinite integrals, definitely go ahead and check out my video on definite versus indefinite integrals. It has a excellently detailed explanation of the difference between the two and what we use each for. So this is a definite integral, so you should know that we're taking the integral over the interval, sum a and b. We're going to have a function, and we're going to say f of x dx, and it's going to give us some value of area, right? Which is how much is underneath the curve. How much area is underneath this curve from A to B. That's all this is saying. So in this case, though, we're just having f of y evaluated at dy. That's the only difference. That's it. End of story. So let's look at a sample function here. Here's what we're going to use. I want to find the definite integral over the interval 1 to 5 of 3y squared plus 4y plus 1. So this is pretty easy, and straightforward enough. So let's go ahead and find the indefinite integral, because that's our first step here. Remember the 3 steps. The first step is the first 3 steps to finding a definite integral. Find the indefinite integral. Second step, substitute values. Third step, go ahead and find your upper bound or your upper limit of integration. Subtract the lower limit from it, and you get your area. Ta-da! You're done. So that's all we have to do here. So we'll take this step by step. Let's work on the. Let's look at the indefinite integral here. Sorry, that's from another presentation. All right, so let's find the indefinite integral. Okay, so 3y squared. This is just, we're just going to use this neat little rule that we have. If you've seen my other videos, you may almost definitely have seen the surface before. When we're taking the antiderivative of something and it is raised to a power, like this is raised to a 2 here, we can just use this rule. The indefinite integral of x to the nth power dx is just equal to x to the n minus 1 power over n minus 1. It's just that simple. So n in this case is 2 and x in this case is y, so we just have to do some mental math substitution here. And we're going to figure out pretty quickly that this is no big deal. All this is going to be oh wait, I've made another mistake again. I make this mistake a lot, it seems, for some reason. This should be n plus 1 up here. So we have n plus 1. So the coefficient out front, I don't really care about it. It really doesn't matter. So here's what we're going to look at. We're going to be looking at this one right here. So we're going to have, we're going to have 3y to the n plus 1 third over n plus 1 3. Well, what's this? This is just y to the third, right? So that's all we need to worry about. So let's get rid of that and realize that we just have y to the third. So our first thing's pretty easy. Plus 4y. Well, 4y. What are we going to do here? Oh, wait, this is raised to the first power, isn't it? So we can use the same rule. So since it's raised to the first power, our n plus 1 is just going to be 2. So we're going to have 4y squared over the 2 on the bottom. But wait, what does this simplify to? Well, this just simplifies to 2y squared. So that's all we have to keep, is this 2y squared right here. So let's make this even simpler on ourselves. So we're just going to have 2y squared right there, plus 2y squared plus 1. What's this going to be? Well, we need to do really no work here. Just do some backtracking math in your head. What is the antiderivative asking? The antiderivative is asking what function, when I take its derivative, like what function, I've got a function here, I'm sorry, I'm phrasing this poorly. I've got a function, f of x. I'm saying what function, when I take its derivative, gives me f of x. That's all it is. So x squared prime is 2x. So if I ask for the antiderivative of 2x, then you're just going to say, oh, well, I know that if I take the derivative of x squared, that gives me 2x, so the antiderivative must be x squared. It's just going backwards. So since that's all we're asking for, come on, tell me what is going to give me a derivative of 1 when I take its derivative? Well, it's x, of course, right? X prime, and it looks like bloody alpha, sorry, x prime is 1. It's 1, it's always 1. So x is all we need to have here. So look, we're done with this part. We've got this. Now that we've got that, we need to put some brackets around it if we want to be procedurally correct, and put our upper and lower limits, our lower upper limits right here on the outside of that. All this means is that these values are going to be substituted into the expression in the brackets. So our next step, we have done this step right here. Our next step is to substitute this stuff. So let's go ahead and start some substitution here. This should be some pretty easy math. First, we're going to substitute the lower bound. That's the first thing we need to do. So we're going to say parentheses cubed plus 2 parentheses squared plus, and I've written x here, I mean y. In this case, it's the same thing. We have y. So plus parentheses. All right, see that mistake that I made there, just writing that x there casually, is the mistake that you're going to run the risk of, because that type of thing is just a careless error, because when you are doing these integration problems, you're just so used to using the variable x that when you have to do a simple problem like this with respect to y, or when you have to do a more difficult problem where you're integrating implicitly with respect to y or to t or to some other variable or unit there, it's really, really easy just to say, oh, well, it's x, because x is what you have on the brain the entire time, because that's what's drilled into your head. So just be aware of that potential mistake and potential pitfall. All right, let's continue. So we have that. I'm writing these parentheses. This will not save you time, but this will prevent mistakes. So I say that throughout a lot of my videos. I want to prevent mistakes, so I'm just writing these parentheses, and then we can go back in and plug in our bound here. So let's go ahead and plug in this 1. All right, so this math should not be giving anybody any headaches. We have upper bound, lower bound. Go ahead and write this here. Okay, this math, like I said, should not be difficult. All we're going to need to do is some simple math. So 1 cubed, that's 1 last time I checked. 1 squared, remember, hey, don't multiply these and then raise it to the power, and then multiply. So 1 squared is just 1 times 2 is just 2. So we're going to have 1 plus 2, and then just plus 1. Well, 1 plus 2 is 2, plus 1. Well, this is just 4. So now we've got 4. So we're going to keep this over here as our lower bound. Now let's go ahead and do this entire procedure again for our upper bound. Oh, drat, I'm so sorry. I should have used the eraser. Okay, so we have 4. Let's do this entire thing again for our upper bound. All right. So now we're looking at, now we'll change colors here for the sake of being able to see stuff. All right, let's do our upper bound. So we're going to input 5 into each of these. All right, now 5 cubed, well, that's 5 times 5 times 5, and so that's just 125. 5 times 5 is 25 times 5 is 125, so 125 plus 5 squared is 25 times 2 is just 50, and then plus 5. Well, we add all this together, 125 plus 150 plus 5. Well, this is 175 plus 5, so we have 180 here. All right, and now we have our upper bound, which is 180. So now what's our next step? We have this information, so we have done this step, we've substituted, and now we have our upper bound, we have our lower bound, so we need to subtract them. So we said that our upper bound was 180, right? So we have 180 minus our lower bound, which was 4. Well, this is just equal to 176. So 176 units squared is how much area would fall under this part of the function. We're just doing it with respect to y. So, wasn't scary, wasn't difficult at all. Alright, we're good to go. That's it. We've completed all of the steps we needed to do, and we found our area.